Hey guys, in this tutorial, we will create a golf ball in Grasshopper using Weaverbird and a few simple components. Before we start, make sure you have installed Weaverbird from Rhino's package manager. You can follow this tutorial in Rhino for Mac and Windows. We will begin with the Weaverbird's mesh Icosahedron component. This gives us a uniform point distribution across the sphere. If you don't see the mesh edges, go to the display settings in Grasshopper and enable Mesh Edge Preview. By default, the icosahedron only has 12 vertices, which isn't enough for our dimples. To increase the density, we will use the Weaverbird's Loop Subdivision component. Each subdivision increases the vertex count from 12 to 42, then 162, and finally 642. This gives us enough resolution to generate a realistic dimple texture. On the other side of the definition, let's create a sphere with a radius of approximately 42.67 millimeters. This will be our base golf ball geometry. Next, let's extract the mesh vertices from the icosahedron using deconstruct mesh. These points will define the center of each dimple. To align them perfectly with the golf ball surface, we will use surface closest point to pull these mesh points onto the sphere. This gives us the UV coordinates that will help us generate normal planes perpendicular to the sphere's surface. Now, let's build the dimple texture using spheres. Before doing that, I'll go back and set the subdivision count to 1, just to keep the computation light while we test everything out. Once we are sure the logic works, we can increase it for more dimples. On each normal plane, create a small sphere with a radius of around 5.8 millimeters. Then move these spheres slightly in the normal direction, outwards towards the golf ball. This creates that concave dimple shape. If you're enjoying this golf ball texture workflow and want to learn how to build advanced parametric textures like this, check out our Grasshopper Masterclass and Advanced Parametric Texture Workshop at Cademy.xyz. Both are live, hands-on course made for industrial designers, helping you master Rhino and Grasshopper through real product examples. You will find the link in the description below. Finally, we will perform a solid difference, subtract all the small spheres from the main golf sphere. This operation might take a few seconds to process, depending on the subdivision level that we have set at the start. You might notice some small artifacts near the poles of the sphere. That's due to overlapping seams. To fix that, simply rotate the base sphere on a random axis before performing the boolean difference. Once the subtraction is done, we can preview our golf ball. Use a custom preview node. Add a white material to give it that clean, polished look. And there you have it, a fully parametric golf ball made entirely in Grasshopper 3D. You can adjust the number of dimples, depth, spacing using the different sliders, and create different variations of the golf ball.